Thursday on the 7th of January, you guys will be able to solve systems by substitution, section 5.2, okay? So in the previous section, we learned how to solve systems by graphing. We figured out where they intersected, okay? Same idea. We're going to figure out the solution where the equation overlaps, okay? So if you're to graph it is where the intersection is, but this time we aren't going to use graphs, okay? It's just going to be wherever, whatever x and y coordinate, whatever x and y combination works for both equations, okay? So substitution, a lot of times in sports, okay, and it happens in other places. We'll all use other analogies too. Sports is the big one. A coach will substitute one player with another, and they play the same position, right? Okay, like let's say, for example, okay, I'm a soccer coach. I'm probably not going to put a striker, okay, a forward attacking player, for those who don't know soccer, in as keeper. Okay, the goalie. That's probably not going to happen, okay? More than likely, okay? Maybe basketball, okay? I'm not going to put my post in at the point guard. Okay, probably not going to work that well, okay? Or vice versa even, okay? Volleyball, I'm probably going to have somebody who's a defensive specialist go up and play middle blocker. Okay, more than likely not going to happen, okay? Not that someone can't play two positions, but it's more than likely you aren't going to have them do that because they're more skilled or more ready for another position, okay? They're more ready for another place. Or how about this? You go to a restaurant, okay, and you order a meal and it comes with a side of fries, okay? And it gives you a list of options of things you can substitute. What kind of things can you normally substitute for like a side of fries?
Broccoli.
Okay, mashed potatoes, tater tots, broccoli, mac and cheese, like things like that, right? Like other sides. Fruit cup. Are you able to substitute in like a second sandwich for a side? Okay, no. How cool would that be though, right? Like I would do that all the time, okay? Please, you get more food. But, what was that? You're going to stick with the mac and cheese? But, okay. So, but you have to substitute in something very similar, right? You can't substitute in something very different like a sandwich, okay? Sandwich and a side, very different types of food, okay? And very different prices, quantities, all that kind of stuff. So same idea, okay, or band, for example. Okay, let's go with another example with band. I'm probably not going to take somebody, we're assuming Mrs. Harvey probably isn't going to have somebody the day of the concert who normally plays trumpet and say, why don't you go play flute today? Okay, that's probably not going to happen, right? Okay, it's just not realistic. What was that?
I said that would be the loudest flute ever.
It would. And it'd probably be like, I mean, I doubt they could even get like the way to actually blow to make the flute play correct either. I play trumpet and I know I sure couldn't play the flute very well if I just picked it up and tried. I need quite a bit of practice, okay? So there's all sorts of different analogies we can make. So we're going to do the same thing though with variables and equations, okay? So we're going to have x's and y's, but we're only going to plug in what is comparable. We're only going to substitute what is comparable, okay? So here we have two equations, y equals 2x and y equals x plus 5, okay? Y equals 2x and y equals x plus 5. Now equals means that they're the same thing, okay? Equal, equivalent, means that they're the same thing. So if I say like 4 quarters equals $1, that's because 4 quarters has a value of $1, right? Okay, they're the same thing when you're spending money.
Maybe.
Y is equal to 2x. Y and 2x are interchangeable. They're the same thing. Okay? Y is equal to x plus 5. They are the same thing. So what we can do...
Same thing.
Yeah, oh, totally. Okay? So what we can do is since y is equal to 2x, we can take this 2x and substitute it in for the y because they're the same thing. So we're going to rewrite the bottom equation, and instead of y, we're going to put 2x equals x plus 5. So we're taking that second equation, we're substituting this y for 2x because we're told in the first equation they're the same exact thing. Now, when you substitute, whether it's in sports or a restaurant or wherever else you can talk about, is the original person or thing still there?
Yes.
Is it still like on the field or in the meal? Like
No.
No, it's not, okay?
No.
So if you go and substitute in for somebody else, that person is no longer there. If somebody in for you, you're no longer on the court or field or whatever arena you want to say. Okay, if you're getting a meal and you substitute the fries for mac and cheese, you don't get fries and mac and cheese. You get the mac and cheese instead of. So just like here, when we're substituting this 2x for the y, we don't have y over here still. We have 2x instead of it because they were equal. Now we create this new equation. 2x equals x plus 5. If we just solve this equation randomly by itself, would we be able to solve that like we were back in chapter 2 earlier on?
Perhaps.
I think so.
Could you do like where you get the x to, so you move the x to the other side by subtracting 1x?
You're nailing it. We would move the x to the other side by subtracting 1x, and we want to move it away from that constant of 5. 2x minus x is just 1x, right? Or x. And what is x minus x? 0. That's why we do it. We get rid of it over there. And so we just have x equals 5. Hopefully we're starting to remember a bit more how we solve these equations, okay? I think that's our first equation we've actually solved for like x equals a number since we've been back, okay? So first one this year. Okay. So now we know x is 5. But these are ordered pairs. Yes, your last class to me, when we had our answers, we got an x comma y, right? We had an ordered pair. We got 2 numbers. So how many numbers do you think we're going to need today?
2.
Probably 2. Okay? Probably 2. So we have our x. So what do we still need to get?
Y.
The y. So here's what we're going to do. We can take our x is 5, and we can plug x into either of these 2 equations. And you can pick. Does anyone have a preference on whether they would like to plug it into the top or the bottom right now? Cool. I heard the top. We'll do the top. So if I, instead of y equals 2x, y equals 2. And what was 2 doing with x? What operation? Multiplying. So 2 and 5 are going to do that same exact operation. So we're going to have y equals 2 times 5. And what is y equals 2 times 5? What is y then? 10. And if you were to plug it in the bottom equation, what's 5 plus 5? 10. Do you get the same answer? So did it matter whether we picked the top or bottom? No, it really didn't. Okay, sometimes we're going to find one's easier. But now we have x is 5, y is 10. So what we can do is we can write that as an ordered pair. 5, comma 10. Does anyone know why I put the 5 first and the 10 second? Because 5 is the x and it's x, comma y. It's alphabetical. Very good, very good. Okay, I heard a few different answers there, and I think I responded to them. But those were all good answers. 5, comma 10, that is our answer. Does this answer look very similar to an answer we would have gotten on the homework we turned in today? Yeah, it does, okay? Because we're still solving a system. So if you were to graph these 2 equations, they would intersect at 5, comma 10. That is where they would intersect. Okay, questions on that one before we continue trying this new method on other problems? Okay, let's try example 2. Example 2, we have y equals 2x plus 1 and y equals 3x minus 4. So we're told y is the same thing, it's equal, the same thing as 2x plus 1 or 3x minus 4. So what we can do is we can take this 2x plus 1 and plug it in for y in the bottom equation and rewrite the equation. Can somebody tell me what this equation would look like? Okay, go ahead, Eli.
2x plus 1 equals 3x minus 4.
That is exactly right. 2x plus 1 equals 3x minus 4. This bottom equation is exactly the same, except y is replaced with 2x plus 1. It was substituted for with that. Yeah, Abby.
Wait, is it okay? So, like, I solved it, and instead of subtracting 3x from 2x, like going to the left, I did minus 2x, so I have to do it.
Yeah, great question. So Abby's saying, okay, now that we're solving this, because this is what we have to do now, is we have to solve for x in this equation that's familiar to us. Is it okay? Do I have to subtract 3x and move to the left? Or can I subtract the 2x? I actually recommend subtracting the 2x and keeping our x's positive. We have a choice here, and I would recommend subtracting 2x to keep it positive, okay? So let's go ahead and do that math move. Subtract 2x from both sides. 1 equals x minus 4. Well, now what do we have to do to get x by itself?
To add 4 to the other side.
Add 4 to both sides. And 1 plus 4 is 5. X is 5. X won't always be 5. It just happens to be for the first two. In case you're wondering, it's not like some sort of pattern like X is always 5.
You sure about that?
I am. How cool would that be, though? It'd make it a lot easier, right? Yeah. So now, any questions on how we got X before we move on? Okay, Elijah?
Why would you do you subtract 2x to 3x? Shouldn't that be 1x? So I guess that'd be the same.
Yeah, it would be the same thing. Yep. I love it. You answered your own question as you asked it. You're like, oh, okay, yeah. I love that. And if you want to call it 1x or x, cool beans. So now what do we have to do since we found x? Find y. Okay, how do we find y?
Plug into the top.
Plug it into in really either equation, okay? Alice, which equation do you want to plug it into, the top or bottom?
Top.
Cool beans. We'll plug it into the top equation. Any reason you chose the top?
It's positive.
Okay, there's addition instead of subtraction. Okay, that's a fair reason. Any other reason why we might want to choose the top over the bottom?
Smaller numbers.
Smaller numbers. Okay, typically, do we rather like working with smaller or larger numbers in math? Usually smaller, right? Unless we're talking about our bank account, we usually like working with smaller numbers, okay? So let's keep that trend going up and work with small numbers. So we'll plug it in the top equation. Y equals 2 times 5 plus 1. And 2 times 5 is 10. And 10 plus 1, as Abby said, is 11. Any question on how we found y? If you had plugged it into the bottom equation, you'd get the same answer. You'd have 15 minus 4 is 11. Okay? So now, how do we write our answer now that we have both numbers? X comma y. And for this case, that would be what? 5 comma 11. Very good.
Okay.
Oh, neat. It's not mine. Well,
January, February, March. It's my birthday.
okay, neat. All right. Any questions on this one, guys?
Of October.
Okay.
We all have the same birthday.
Oh, neat.
A couple months different.
Oh, okay. So like same day of a month.
Me and Cece are born exactly a month apart. She was born in June and I was born in May. Like on the 11th. Both.
All right.
Didn't Amy have the same birthday?
No, just thought that one.
Thank you for making that joke. I appreciate that.
His birthday is December 19th, not the 13th or the 16th.
My
Like I
birthday's
thought.
in 2 weeks.
For a long time.
Oh, yeah, neat.
My birthday's this
18.
month.
Yeah. Ooh. All right. So now I want to go over something real quick here. Okay. Backtracking on how we started this. We plugged in the 2x plus 1 into the bottom equation to start. Well, here's the thing. If y is equal to 3x minus 4, it's the same thing as 3x minus 4. Could we plug that into the top equation? Could we substitute that in for the y up there? The answer is yes. You'd end up getting 3x minus 4 is equal to 2x plus 1. What's different from this in the red versus this in the orange? Look at it for a second and think about what's different between this in the red and this in the orange. They're just flipped. Would that affect anything else? No. It wouldn't affect a single thing. Okay? They are just flipped versions. So, whether you substitute the 3x minus 4 in for the y or the 2x plus 1 in for the y, it's okay because y is equal to both of them. Y is the same thing as both of them. They're interchangeable. Okay. Let's continue on to the next example. Woo!
When's your birthday? Like what day?
October 6th.
That's a cool birthday.
Oh, thanks. My parents thought so.
On October 4th, yes, what day is it?
It's October 3rd, actually.
October 3rd.
Yep. On October 3rd, you asked me what day it is. It's October 3rd. Okay. Mean Girls.
Two girls.
It's actually one of the most well-known references from the movie. It's just a classic, silly reference. Example 3, 2x plus y equals 5 and y equals x minus 4. Now, in the previous examples, we had y equals in both of the equations. Do we have y equals in both of the equations here?
Yes.
No, we only have it in one. But we still know y is equal to x minus 4, okay? So in the last example, we said we really could plug it in for either one. On this one, we cannot plug in like 5 in for anything. Because 5 is not just equal to y. 5 is not just equal to x. 5 is equal to all of 2x plus y. So it's not the same thing as y. It's the same thing as 2x plus y. Whereas x minus 4 is the same exact thing as y. So what we're going to do here is we're going to take this x minus 4, and we're going to plug it in for what variable in the other equation? Not x.
Why?
Y. Because it is equal to y. It's the same thing as y. So because they're the same thing, they can be replaced with it.
You said why, and you said because.
Right? Okay, 2x plus y equals 5. So instead of y, we're going to have what we're replacing it with. So we're going to have 2x plus x minus 4 equals 5. So we're going to rewrite that top equation, and every single thing will stay the same, except instead of y, we have x minus 4, because that's what it's equal to.
Can we add 2x and x?
Yes, we can. Well, and that's exactly what our first step should be, although you could have another first step. But that's a great first step, okay? That's what I would recommend. Before we continue on solving it, any questions on how we got here? Okay, in that case, I'm going to actually ask you to finish off this problem. I'm going to ask you guys to finish off this problem. Finish solving for x, solve for y, put it in an ordered pair. When you have that, or when you have questions, let me know by raising. All right, so a good first math move is to add 2x plus x, okay? It's not what you have to do first, but I'd recommend it. So 2x plus x, they're on the same side of the equal sign, so we get 3x minus 4 equals 5. Now we add 5, we add 4 to both sides. 3x is equal to 9. Divide both sides by 3, and x is 3. Now, when you go back and find y, does anyone have a preference on which equation they want to use?
The smaller one.
Second one.
Okay, the second one. Okay, I heard because it's smaller. Okay, why else might be a reason?
It's only one less number.
Okay, it's only one step. There's less numbers. Okay, y is already by itself, and that's the one we're trying to find. So if you have an equation where the variable you're trying to find is already alone, it's pretty wise, I'll say, to choose that one, okay? I think that would be a good decision. Not that it's necessarily the only decision, but I think it's a good decision, okay? So y is equal to, and let's make sure we give ourselves room, 3 minus 4. What is 3 minus 4? Negative 1. So our final answer ends up being 3 comma negative 1. Questions on that? Questions on that one at all? No? Okay, Gucci, okay. Now, number 4, we have a slight difference. What's our slight difference here in number 4 compared to the first 3? Okay, Alice. X is by itself, not y, right? Well, is that going to change what we can do?
No.
Not really, okay? Instead of just substituting 2y minus 4, where are we going to plug that in now?
Into the...
I heard it. Into the x. Remember, like I said earlier, you have to plug it in for what it's for, okay? Just like in sports, you sub in position for position. Food, you sub in a side for a side. Band, an instrument for an instrument, okay? That kind of stuff. You're going to substitute it in for x now. So in the bottom equation, as you write it, you'll have 2y minus 4 plus 8y equals 16. Okay, any questions on that? Hey, Mr. Crossell, how'd you get that? I'm completely lost. Wait, why is it a 2? Anything like those. Okay, now let's go ahead and solve it then. So 2y and 8y, what can we do with those? We can combine them. We can add them, okay? What's 2 plus 8?
I don't know.
10.
What is it?
So 10y minus 4 equals 16. Josh, what would you do next? Add 4. 10y is equal to 20. Okay. Jack, what would you do next? Divide by 10, I agree. And y is equal to what? 2. So now, we don't need to go back and find y. Courtney, what do we need to do? Go back and find x. Courtney, do you have a preference of which equation to use? You can choose the top or the bottom. Okay? You want to choose the top. Now, why do you want to choose the top?
Smaller number.
Okay, smaller numbers, okay? 2 and 4 are smaller than 8 and 16. Okay? Any other reason we might want to choose the top? It already equals x. And that's what we're trying to find. So if it's already equal to x, that's going to be one less step we have to do. So you could do the bottom. I would choose the top personally. X is equal to 2 times 2, like what ballerinas wear, 2, 2, minus 4. What is 2 times 2? 4. Jaden, what's 4 minus 4? 0. So our answer to this one ends up being what, Jocelyn? Yeah, 0, comma 2. X, comma y. So remember, it's alphabetical, okay? Some of us might have accidentally put 2, comma 0 because we're used to putting whatever number we solve for first. Just be careful, we're always putting the X first, okay? Any question on these 4?
No, sir.
All right, Gucci game. Okay, go and give yourselves a slap on the back. Okay, not quite. We have a few more examples, okay? So occasionally, we have to solve for a variable before we can substitute, okay? We noticed in those first 4 examples, we had a variable by itself, at least in one equation, every time. Here on number 1, though, do we have any variable completely by itself? Like it's the only thing on its side of the equal sign? No, okay? We have an x with a coefficient of 1, an x and y coefficient of 1, but they all have other things on the side of the equal sign. So we have to do, first, get a variable by itself. Now, as we're choosing which variable to get by itself, of these 4 options, I think there's one that is a worse choice than the others.
The bottom one is worse.
Okay, I think there is one variable. There are 4 variables, a top x, a top y, a bottom x, and a bottom y. I think there's one of the 4 options, which is the one you probably don't want to choose. You still can, but it's going to make your life harder, okay? Eli, which one do you think it is?
4y.
That 4y.
Okay.
Does anyone know why we might not want to get that one by itself? Abby, what are you thinking?
Because the bottom one is already by itself.
Okay, the bottom y is already by itself comparatively, has a coefficient of 1. Alice, what are you thinking?
Because the 4y will be covered in get one by itself because it's
Okay, the 4 is already with it, so it'd be harder to get by itself. Corey, do you have anything to add to that?
Because later on you're going to have to divide by 4, so it's going to be hard to divide 6 by 4.
And that's exactly correct. Elijah, is that what you're going to say?
Turn into a fraction.
Yes, and that's exactly true as well, okay? So they're both 2 ways of saying the same thing. If we were to, don't write this down, if we were to try and get that y by itself, I'm just going to rewrite this, x plus 4y equals 6. If we were to get that y by itself, we'd have to subtract x, 4y equals negative x plus 6. Then we're going to divide every single thing by 4. And we're going to get fractions. And 6 over 4 would reduce to 3 over 2. Do we want to deal with fractions if we can help it? No, we really don't, okay? If we can help it, we would rather not deal with fractions, okay? The best we can. So I think the wisest choice is to pick one of the other 3, okay? For that reason. Purely because 4 will not go evenly into 6 and 1. 4 won't go evenly into 6 and 1. So let's back up and let's pick a different option here.
Can you just plug in some variables?
Like, are you saying like guess and check? Let's see if like 3 comma 2 works.
If you put 1 in for y and 2 in for x, it works.
In the top equation and in the bottom, okay? So you can, but here's the thing. That's going to take a long time on some problems. Like way longer than it honestly ever should. So guessing and checking is the method it's called, because you guess something and then you check to see if it works. And then you go back and guess and then check, guess and check over and over and over again. It works. It takes a lot more time overall.
I guessed and checked.
I know. Okay, so let's say we're getting a variable by itself, okay? Let's say we get the top x by itself. If we were to get x plus 4y equals 6 and get the x by itself, we would subtract that 4y. Is that correct? Okay. So we then have x equals, and you could honestly either do 6 minus 4y or negative 4y plus 6. It really doesn't matter. Okay. It's not slope-intercept form, so it really doesn't matter, okay? Now, are there any fractions? No, that's kind of nice, right? So if we got that variable by itself, once again, you could pick either of these other 2 variables to get by itself. You'll still get the same answer. If we get this variable by itself, x is now by itself, so it's now the same thing as negative 4 plus 6. So I can take that and plug it in for the x in the bottom equation. I can't choose the top equation. Can anyone tell me why I can't choose the top equation?
Because there's,
Jaden?
Because that's the one that you solved.
Yeah, that's the one I'm solved. I can't plug it into itself. I can't plug the equation into itself. I have to choose the other equation, okay? Very good, Jaden. So let's go ahead and rewrite this equation. Instead of x, we're going to have negative 4y plus 6. So negative 4y plus 6. Now I continue on with the rest of the equation. Plus y equals 3. Negative 4y plus 6 plus y equals 3. Any questions on how we got to here in the purple? Okay, now at this point, does this turn it just into a problem like we just had? Totally does, okay? So let's go ahead and keep going through our math moves. Negative 4y and y, what's that become? Negative 3y. So you have negative 3y plus 6 equals 3, okay? Now what would we do, Elijah?
Subtract 6 from each side.
I agree with that. Subtract 6 from both sides. Get that constant, I couldn't think of the word, get that constant away from the variable. Negative 3y equals, what is 3 minus 6? Negative 3. Negative 3y equals negative 3. Now what? Divide by negative 3. Y is equal to 1. Now are we fully done yet? No, what do we have to do?
plug it in.
Plug in the y. Now here's the thing. We might be looking at this one to try and plug it into. But is it possible that we could make a mistake on the way to get this one? To get x by itself? Yeah, it is. Is it possible that is it as likely that there's a mistake with the equation that was already given to us? No, it's a lot less likely there's a mistake with the equation that's given to us than the equation we've already moved around. So we want to plug it back in to one of the original two equations. Okay, we want to choose one of the original two equations. Does anyone have a preference on which one of the two original you'd rather choose? Okay, Elijah?
Bottom one.
You're saying the bottom one. Why do you think the bottom one?
Because there's no numbers.
There's no coefficients, just one. Okay, and so all you're gonna have to do is subtract, right? Okay, I would choose the bottom one. Here, they're both about the same difficulty, in my opinion.
I like the top one because I like using more
Okay.
easier, like the equations that we had last time.
Okay, yeah, and if you would rather do the top one, or Kel saying she likes that, she likes kind of working with those numbers. It just kind of keeps it more similar for her, like the other ones we've done. And correct me if I quoted you wrong or paraphrased you wrong. Then feel free to do the other one. You have the choice here. You should get the same answer, which is the nice thing. X plus 1 instead of y equals 3. Subtract 1. X is 2. So 2 comma 1 is our answer. Okay, any questions on that one? Yeah, Jaden.
Could we just make the equation into the normal y equals mx or y equals x plus b and then do it? Just because.
Okay, so you're saying could we get these in a slope-intercept form and then solve by like we did on these?
Yeah.
Yeah, totally. So you can get any variable you want by itself, but just remember, if we got the y alone on the top equation, that's when we got those fractions. So you can do that, but sometimes it creates fractions. So I typically advise getting one that doesn't have a coefficient, if you can, to just avoid the fractions. Does that make sense?
Yeah.
Okay, good question. Any other questions before we move on? Okay, the only thing that's different about this versus other examples, we had to get a variable by itself. Example 2. There's a tie for what's the best choice here. How many variables do you think there's a tie between? On number 2, there's a tie out of the 4 options. And I'll tell you it's more than 1, less than 4. So it's either 2 or 3. How many variables do you think this tie is between? Okay, why don't you show me on your hands real quick, either 2 or 3, okay? 2 or 3 on your hands real quick, okay? Okay? Seeing a lot of 3s, seeing a couple 2s, okay? I'm actually going to say it's 2. Okay, I'm going to say it's 2. Okay, I think 2 are the best options. And then I think there's one that's an almost as good option. Okay? Can anyone tell me which ones I think might be the best options? Okay, Elijah.
The X's.
The X's. They're positive ones with a coefficient. Why might I say the y, the negative y here, is an almost as good option? It's negative. Let's just play pretend for a moment. Don't write this part down. And let's say I get this y by itself. Y subtract the x. Negative y equals negative x plus 5. Am I done yet? No, I still have to take care of that negative by dividing by a negative 1. So that's one extra step, right? So I took 2 steps to get there. Not terrible. No fractions, so that's nice. But I could get the x by itself in how many steps? 1. So it comes down to a, hey, would I rather do 1 step or 2 steps? I mean, for me, that's what it comes down to. But if you would rather, like Jaden was saying earlier, I really want that y by itself. Well, you can. You can. There's nothing wrong with it. It's going to be 1 extra step. There's nothing wrong with it. You can still get the right answer at the end. Okay, questions on that? Okay. So now that we have this variable by itself, and once again, we could have gotten the top x by itself just by subtracting 2y. What can we do with this y plus 5? Plug it in where? To the x, which one? The top one, because it's the other equation. Okay, can anybody tell me what that would give us if we plug in that for the x? Okay, Courtney?
Y plus 5 plus 2y equals -1.
That's exactly right. Y plus 5 plus 2y equals -1. Y plus 5 replaces the x. Then we continue on, plus 2y equals -1. Questions on this so far? Alrighty. Okay, we'll go and continue this one on real quick. Y plus 2y is 3y. Plus 5 is -1. Equals our -1. Brady, now what? I agree. -5. Let's get that constant away from the variable. 3y is equal to -6. Isaac, what would you do now? When 3y is equal to -6? Divided by 3, right? And y gets -2. Now we have to plug it back in. And like I said earlier, we want to pick one of our original 2. Just because there's a chance that as we worked with this one in the blue, that we made a mistake. There's a chance. Okay? And let's just not take that risk. So as we plug it into one of the original 2, does anyone have a preference here? Sarah, do you have a preference on which of the 2 you plug it into?
I use the one with the numbers.
Okay, so the top one. Okay, so Sarah wanted to use the top one. Sure, we can use the top one. These, they're both pretty even in my opinion, because here you have a negative and a 5, so a bigger number than 1. Here you have a positive, but you have to multiply by 2. So in my opinion, they're about equal. X plus 2 times -2 equals -1. Well, 2 times -2 be -4. X minus 4 is equal to -1. Add the 4. X is equal to, see not 5, 3. Yes, Raquel?
What if you put, instead of going into the thing, what if you put x equals the little thing that you have above it? The x equals y plus 5.
Yeah, what if we plug it into here? So as I was saying, you can plug it into here and you'll, as long as we did nothing wrong, you'll get the right answer. But this is the one we did stuff to, so there's a chance we made the mistake. Yeah. Yep, thanks for asking. I'm glad that seems to make more sense. Okay. Any other questions? Okay, Emily, how should we write our answer? Yep. I agree. 3, -2. And then we'll continue on now. On example 3 and 4, how many best options do you think I would say there are?
1.
1, I'd agree. Which one do you think would be on example 3? That bottom X, right? Okay. Why is that the best option?
Because there's no number with positive.
Positive with no other numbers. Okay. What option do we think is going to be the best over here on example 4? Why? Same reason again, right? Okay. So if that ever happens where you have the choice, I would say analyze the problem. Let's look at what's going on. Figure out what your best choice would be, okay? Once again, you can do the others. You're going to create more work for yourself. But you can, okay? Give me a thumbs up if you're feeling good about these. Thumbs down if you're not. Okay, be honest with me here. Thumbs up if you're feeling good about these. Thumbs down if you're not, okay? Be honest here. Okay? Okay, here's what I'm going to do, okay? Getting some good reactions here. I want us to try number 3, okay? So I want us to try number 3, okay? On our own right now. When you have it or have questions, I want you to raise your hand, please. Okay, so let's look at this one. Now, once again, which variable do you guys probably think would be the best to get by itself here? The bottom x, right? Okay, so we're going to add 4y to both sides of the equation. Negative 4y plus itself is 0. X equals 4y plus 11, or 11 plus 4y. Really doesn't matter the order you write it in. Now that we have an x by itself, we have a variable by itself, we can plug that in for the x in the other equation. Now this is the part that's different though a little bit, right? Because now we have 4y minus 5. Now what's 5 doing with that x? Multiplying. So we're going to put all of the x in, the 4y plus 11, in parentheses, and it's going to do the same thing it would have been doing. Just like when you substitute a player in a game for someone else, okay? They're going to be fulfilling the same role, okay? And that's going to be equal to 9. Any questions on this part up to here? Okay, so from here we have to distribute. Now once again, a flashback to last semester, it can be helpful to think of that negative as plus a negative 5 sometimes. So as we distribute, you have negative 5 times 4y. So you have 4y minus 20y, negative 5 times 11, minus 55 equals 9. Questions on up to here so far? Okay, if you didn't have this, are you writing this down? Okay. Now, at this point, we can combine like terms. 4 and negative 20 combine to be negative 16y minus 55 equals 9. Add that 55 to both sides to get that constant away from our variable. Negative 16y is equal to 64. At this point, we divide by negative 16 to get the y by itself. And y is equal to negative 4. Our answer ends up being, y is negative 4, but we need to go back in and plug it in for the x. Questions on how we got to the y? Alrighty, so let's plug this back in to get our other answer. So we can plug it into either equation. You guys have a preference between the top and the bottom? Isaac, which one would you rather do, the top or the bottom? Okay. Bottom, okay, sounds good, because you don't have to deal with the 5 with the x. You don't have to divide at the end. I like the reasoning too. X minus 4 times negative 4 equals 11. Well, 4 times negative 4 times negative 4, really. X plus 16 equals 11. Subtract the 16. X is negative 5. So our answer ends up being negative 5, comma, negative 4. A bit bigger one, right? A bit bigger one. Okay. A little more challenge for you guys, though. Any question on that? Any question on that one at all? Okay. Let's go ahead and skip example 4, but let's talk about the last 2 examples here, okay? Does anyone still need that previous page? Okay. On the next slide, though, I'm just going to start talking about it right now, though, okay? On the next slide, we're going to be talking about when we have infinitely many solutions and no solutions still, okay? We can still come across those. And once again, that no solution was parallel lines because parallel lines never intersect. Infinitely many, the coinciding lines, the same lines, because they overlap. Every point is shared. So we're going to solve these the same way, though, to start. So everything's going to look like normal to start, okay? Just like with graphing. Do you have a variable by itself already? Yeah, that's handy. Okay, we like those more. Those are the easier ones typically. I can put that 2y plus 3 in for the x in the other equation. So I have 2 times 2y plus 3 all in parentheses. Okay, this is another reason I really substitute in parentheses. Minus 4y equals 1. Any questions on why I substituted that way, how I got what I got, any of that? Okay, so now we'll distribute. 2 times 2y is 4y. 2 times 3 is 6. Excuse me, minus 4y equals 1. Questions on up to this step? Alrighty. What is 4y and that negative 4y? What are those combined to be? 0. You don't have any y's left. So f with 6 equals 1. Wait a second. What happens when we get down to an equation that is never ever true? No solution. These are parallel lines. They're parallel lines. They never touch. They don't share any points. There will never be an ordered pair that works for both equations. Question on that one. The nice thing with these, they end up being a little bit shorter of problems. Because you're done after like a couple steps here. Last time we were taking bets a little bit on what we think the other one's going to be. What do we think this other one's going to be? Probably infinite line. It's going to be our coinciding lines, the same line, okay? Do we have a variable by itself? Gucci. Y is by itself. We can take that 2x plus 5, put it in for the y in the other equation. Give us 4x minus 2 times the quantity of 2x plus 5 equals negative 10. Becomes a long one. But everything stays the same in that other equation, that top equation, except y is replaced, substituted with 2x plus 5. Question on up to this step. Alrighty, so now we distribute that negative 2. We might want to make sure to make that a negative 2. 4x minus 4x minus 10 equals negative 10. Raise your hand if you're starting to kind of see what's going to happen here. Okay, some of us are starting to see what's going to kind of happen here, okay? And if you're not, no worries. We got more steps. What's 4x minus 4x? 0, they're gone. Negative 10 equals negative 10. Is that true? Yeah, always. So what happens when it's always true? Infinitely many solutions. When you get down to no variables, it's true. IMS. No variables, not true. No solution. Any questions on that at all? The only dudes are going to show up at the very bottom here, bottom left corner. Here's the ones I want you to do. Do numbers 1, 2, 5, 9, 13, 17, and 18. 7 problems. 1, 2, 5, 9, 13, 17, and 18. Those 7 problems are the only ones I want you to do.